Okay, this is a question that was on web work when I gave it, and but it's still a pretty cool question because it covers things that are covered in pretty much every calculus class. And the first question says, list the intervals in which f is increasing. So I can draw on this. This is cool, right? I can draw. F is increasing from here to here, from here to here, but the problem is this isn't f, so I got to read the question again. But that's a typical thing students do, and I just got caught by it again. This is the graph of f prime. Yay! Then I say, all right, f is increasing if f prime is positive. Okay, so it's increasing from 3 to 5. All right. Now we're on track to answer this question. If we hadn't figured that out, we would have figured it out way down below at E where it says sketch a graph of f, and you would have said, oh no, I did it all wrong, how horrible. But let's say you catch your mistakes sooner. It says, identify the x coordinates for all local max and min and tell whether it's max or min. Okay, so a local max and min is here at 3 and 5, so it wants to know whether it's a max or a min. Well, what's happening is, if this is f prime, like we were told it was, then it means your function is decreasing and then it's increasing. So if it's decreasing and then increasing, we have a min at 3. And over here, if it's positive and then negative, it means it's increasing and then decreasing. So it must be a max. Okay? So you just figure out what that is doing. All right, so I'm going to go ahead and erase this so we can go to the next question. List the intervals on which f is concave up. F is concave up if f double prime is positive. Well, this is already f prime, so, or if f prime is increasing. Okay, so if the derivative is positive, right? So f prime is increasing over here and over here. So this is x from 2 to 4 and x from 6 to 8. There you go. All right, let's erase this again. All right, and then it says list all the x coordinates of points of inflection. All right, so that means the maxes and mins of f prime. So if f prime has a max or a min, then f prime is equal to 0. Okay, and so then you have points of inflection maybe, but in this case they're going to be points of inflection because nothing weird is going on, and these guys are not occurring on the axis, and they're just doing what you would expect. So at x equals 2, 4, and 6 is where those occur. Okay? Then comes the doozy. Let's go ahead and try to graph f. We're going to try to graph f based on f prime. And so we're going to try to piece together all this information. And so what I'm going to do is I'm going to sort of say, all right, let's look at if this is f prime. Let's see, f prime is positive or negative, and it tells you something about f. So f is going to be increasing between 3 and 5. F is decreasing everywhere else. And then I'm going to use blue to talk about concavity. Right? So I'm going to maybe not go through the whole entire plot so it's a little easier to read. Okay, so this is f prime, so since f prime is decreasing, we have concave down over here, concave up over here, concave down, and concave up. And so what we usually do in calculus classes, we have all these crazy little line plots, and we have pluses, minuses, and stuff. Do whatever you want in order to keep track of the logistics of this type of question, but you have to know that there's 4 possibilities, and I like to draw them out on a circle. All right, and just draw myself a circle to remember that there's 4 possibilities that calculus students are pretty much responsible for. So this is f prime is positive here and here, and then f prime is negative here and here, and then what about f double prime is negative here, positive here, positive, negative. F double prime is positive if you're holding water like this, and it's negative if you're spilling water like over here. This cup is upside down or upside right. And increasing and decreasing people don't have trouble with. So there's the 4 templates. And so you can think about that, and you can think, okay, so actually I'm going to try to draw one more thing on this massive plot, and I know that you don't have that much space to do that, but I'm going to get away with it. Okay, so here in this first region from, 0, let's see, t or x, is it t or x? T is equal to 0 to 2. I am, f is decreasing, and you're concave down. So we're in this situation. All right, so it's going to look kind of like that. All right, and then t is equal to 2 to 3, like from here to here. Then we have f is decreasing, and f is concave up. So this is the situation we're looking at. So it's going to look like that. All right. And then in the next region we have from t equals 3 to 4. Then we have f is increasing, those 2 possibilities there, and concave up. So there we go. If it's increasing concave up, then it looks like that. Okay. And then t is equal to 4 to 5, right over here. We have f is increasing, all right, and f is concave down. So we have increasing, f is increasing, and f is concave down. We're over here. And so we have this kind of situation. Okay, just 2 more of these. It's not that bad, right? It's time consuming, but it's not that bad. Okay, so now we have this situation where f is decreasing and concave down. So we have the quadrant 1 situation. There we go. At least quadrant 1 in my little diagram. And so I'm going to put all those pieces, I've got one more, I guess. I'm going to put them all together, and then I'm going to make a plot. So it seems like, why are we doing all these little teeny mini sketches? It looks kind of stupid, but it'll work. Watch it, it'll work. Okay, so this little piece, one more. T is equal to 6 to 8. So we have f is decreasing, and we have concave up. So here we are. F is decreasing, concave up. Okay, so now we're going to put all those pieces together and try to make a picture out of that. And each of these are 1 unit long except for the first 2. You know what? I'm just going to make this one longer, and I'm going to make this one longer, because, you know what, I'm going to actually grab and drag to show you that this is not a bad way to do this. I'm going to just copy these and find a space to paste it. Alright, we've got all these scribbles over here. And I'm going to really just drag them, and you'll see that it actually kind of works. Put these guys together. There we go. And so we were told f of 0 equals 0. And we don't know what the rest of these things are. It doesn't really matter. Okay, so we just need to do let's see, if this is the axis, then this is at 2, 3, 4, 5, 6, 7, 8. There we go. And it's a perfectly good plot. And you may say, well, how do we know if it goes above the axis or not? It doesn't actually matter. So you could have drawn this thing so that this guy It can't go above the axis until after 3 though, right? Because it needs a chance to increase. But once it increases, you can make it go whoop if you want to, that's fine. Then it has to do this kind of thing. You can make it do just about anything you want as long as you follow the rules. So that would be a perfectly valid function too. As long as you make sure it's increasing where it's supposed to increase, decreasing where it's supposed to decrease, and concave up and down where it's supposed to be, then you have some flexibility with this. And so I hope you have a little bit of fun with that question. I probably won't use this question, but I could do something very similar. So, have fun.